Let's get started. I know this is the last session of the day, so thanks for being here all day and for the last session. My name is Mete Atamel. I am a developer advocate at Google. I'm based in London. And today I want to talk to you about open standards for building event-driven applications in the cloud. I spoke at Porto Tech before, but it was online, so it's great to be here in person, because in-person conferences are 10 times better than presenting online. The slides are on my speaker deck, and the demos I'll show, they're on my GitHub repo. I'm going to share all the links with you at the end of the presentation. So if you want any of this material after today, you'll have all the links. And if you need to reach to me after today, this is my Twitter. Feel free to connect me there as well. All right. Oh, before I start, since I work for Google Cloud, I should mention that we have this Cloud Innovators program. It's for people interested in cloud, and it gives you credits and some personalized experience with Google Cloud. So if you're interested, this is the QR code. Feel free to scan it and join if you like. Okay? And I will have this link at the end as well in case you want to do it then. All right, so let's get started. And by the way, feel free to stop and ask me questions if something is not clear along the way, because I think we have enough time. So yeah, if you have any questions, just raise your hand and I'll be happy to take questions. All right, so let's do a little bit of introduction. Let's say we are building an event-driven application. And let's say this is an order processing system where you receive orders from people and then you try to fulfill them with some services. So maybe you have a front end running on the App Engine, because that's what typically do on Google Cloud with front ends. Then maybe you have a Cloud Run service for payment processing, which is a container service on Google Cloud. Then maybe you have a shipping function running on Cloud Functions. And then, of course, you want to notify users, so maybe you have a notification service as well. And you probably have many, many more services, but I'm just kind of simplifying here. And this is event-driven. What happens is that when a request comes in, the front end does its part. Then when it's finished, it wants to signal to the rest of the system that it's done its part. So it will send this order received event. Now that event goes to a message broker or an event bus. That's kind of the backbone of event-driven systems. Then it figures out which service is interested in this order received event. The payment processor will receive that. It will do its own part. Then it will emit another message, payment processed, and the process continues. But the key point here is that these services, they don't know about each other, they don't care about each other, they don't call each other directly, they communicate indirectly using events, right? And the good thing about this is that because they're communicating indirectly, it becomes much easier to plug in new services. So if you need to add a new service, it's basically just deploy the service and configure what messages it should receive, and that's it. You don't really need to touch the rest of the system. So it allows more flexibility when you're changing your system. Now, in event-driven architectures, you need to decide and communicate a couple of things. First, you need to decide on the envelope of the events. So the events, they usually have two parts. The envelope is the information that you use to route the events, and the actual payload of the event. So that envelope is important because that's how events get routed. So you need to decide on what you're going to use to route your events, and you need to somehow communicate that so that the routers along the path, they know how to route your events. And the second thing that you need to decide is which service publishes or subscribes to what events. So you need to decide that, and you also need a way to communicate that to people so that if someone wants to use your service, they know how to publish events and they know how to receive events. So you need to decide on these things. And the summary of my talk, if you don't want to listen for the rest of this talk, is this. Cloud events, it defines an envelope that you can use. And AsyncAPI helps to document event formats, and it also helps you to document which service publishes or subscribes to what events. So I'm suggesting that we should look into cloud events and AsyncAPI because they really help with these two problems that I mentioned. All right, so let's look into details. So first, let's look into cloud events. And first, let's define why we should even care about cloud events. And let's go back to our event-driven architecture. You know, at the very high level, when you look at event-driven architectures, you have some event sources emitting some events, and you want to send them to some event destinations, right? That's what event-driven is. But of course, there are things in the middle that do the routing of the events, but they also do other things. They do maybe filtering, or maybe they do enhancements of events, so it's not just simple routing. But of course, in real world, things are more complicated, so these event sources, they typically use different mediums. So for example, you might have an event source that's publishing events to a Kafka topic. Then you might have an event source that's an IoT event source. Maybe it's using MQTT protocol. Maybe you have an event source running in the cloud and publishing topics to Google Cloud's PubSub, right? So now, all of a sudden, your middleware gets quite complicated because now you need to deal with multiple protocols, you know, Kafka, MQTT, PubSub, so on and so forth. You potentially need to deal with different formats. So maybe your events are in JSON, but maybe in other systems like PubSub, for example, you want to use something more efficient than JSON, so maybe you're using protobuf or Avro. Your events have schemas, right? So ideally, you capture that schema and you put it somewhere so people can see your event schemas. So reading these events and routing them now you are dealing with a lot of complexity. And Cloud Events can help with this complexity. So what is Cloud Events? It's an open source specification for describing events in a common way. So it's a way of describing events. Instead of us doing, you know, our own way with every eventing system that we have, we can actually adopt Cloud Events that gives us a common way of describing events. But it's not only that, it's also SDKs to read and write these events. So it's not about just describing the events, but also having SDKs to read and write these events. So it does this by defining a minimal set of context attributes. So these context attributes are used to route your events, and we'll take a look at an example in the next slide. And your payload, so whatever you want to send within Cloud Events, goes under data, okay? So whatever you want to send, you can still send it. It's under the data, but you need to define these context attributes that the Cloud Event requires. So let's take a quick look on how they look like. So Cloud Event has two different formats. One is called binary mode. And in binary mode, so here I'm sending a Cloud Event, and you see that there's all these headers with CE dash. These are Cloud Event headers. So you basically specify your Cloud Event via the headers. So first, the content type defines the mode of your Cloud Event. In this case, the content type is application JSON, which means this is a binary mode Cloud Event. Then you have the required attributes that Cloud Event requires. So in this case, spec version, the type of the event, the source of the event, and also the unique ID of the event that you need to specify. Then you have the time and the subject that you can set if you like. Then there are extension attributes. These are extra headers that you can set for your own application. So if your own application needs some extra information to route the events, then you would put them in the extension attributes. These are also optional, but useful in case you need something specific for your application. And then finally, the actual payload, the actual data, is in the body of the message, right? So this is a binary mode Cloud Event, and it's good for receivers unaware of Cloud Event. So if you are a receiver receiving Cloud Event, but you don't understand it, it's OK, because you can ignore the headers and just read the body, and you'll still have the data. So if you have that kind of use case, then it's probably a good use case for binary mode. Now, the other mode of Cloud Event is called structured mode. In structured mode, everything lives in the body. So now this is the same event as before, but first, you have the content type, Cloud Events plus JSON. This means this is structured mode. Then you have the required attributes of Cloud Events. They live within the body. You have the time and the subject. If you want, you can add them. They're optional. You have the extension attributes, just like before. And finally, you have your data under the data field. Now you see this is very similar. The only difference is that instead of using headers for cloud event, you're using the body of your HTTP request to define the cloud event. And structured mode is good for cases where you have a lot of routers, and maybe some of those routers don't understand cloud events. And some routers, they check the headers, and if they don't understand it, they drop the message. So you don't want that. So for those use cases, structured mode is probably better because everything is in the body. And because of that, the routers usually don't touch the body of the messages. So yeah, it's really up to you which mode you want to use, binary mode or structured mode. The SDKs, they support both. So you need to decide basically which one you prefer and which one works better in the environment that you want to use cloud events. All right, so cloud events give us this common format, but it also gives us more. So for eventing formats, you typically would use JSON, but it supports protobuf, Avro, and even XML, which is in draft. It supports different protocols. So typically it's HTTP, but if you're using Kafka, MQTT, or even WebSockets, you can use them with cloud events. It has SDKs for a bunch of different languages. So this makes it really easy to kind of read and write events by just using the SDKs. And finally, a lot of vendors, they also have their own cloud events libraries because, typically you would use the cloud event SDK to read the envelope, but then the data field has the actual event, right? So for that, you would use the library from the vendor to read that actual event that you're interested in. And Google Cloud, for example, we have the Google Cloud Events library, and you can use that to read the events coming from Google Cloud that's wrapped into cloud events. And let me just show you quickly, so that you have an idea how this looks in code. So for example, I'm just going to show one example from one language, and this changes from language to language. But here, I'm reading a Google Cloud Storage event wrapped into a cloud event from C#, okay? So for that, I'm using the C# SDK, and the way you do this is in C# is that you first create a formatter, and then you get this storage object data. So this is coming from Google Cloud Library. So you see I have two libraries I'm using, the Cloud Event SDK and the Google Cloud Event Library. So I'm creating this formatter, and then from the request, I get the cloud event, but I also can get the data, and I have the data as this strongly typed storage object data. So the cloud event has the envelope, so this is the envelope that I have, but I actually can also get the data and have that strongly typed into what I want. In this case, it's a Google Cloud Storage data, okay? So this is how you would do it in C#. If you want to look at, for example, another language like Java, this is from the Java SDK Cloud Events site. So how you do it depends on what framework you use. But if you look for something simple, like a simple HTTP, for example, in there, you need to create a message reader and writer. So this is from the SDK. And then when you get an event, you basically just use the message reader to convert it into cloud event. So this is how you do it in Java. And every language has its own way. But basically, the idea is that you get an HTTP request, you use the cloud event SDK to get the cloud event, and from there, you use the events library from your vendor to read the data field of the cloud event. All right. But you need to keep some things in mind. For example, in cloud events, there's something called batch mode, where you can set multiple events in a single request, but it's not supported in all protocol and SDK combinations. For example, JavaScript SDK supports HTTP and Kafka batch mode, but it doesn't support MQTT batch mode. Not all event formats are supported in each SDK. So JavaScript supports JSON, but not the rest. Not all protocol bindings are supported in each SDK. Again, JavaScript SDK supports HTTP and Kafka, but not the rest. So the point of this is that if you want to use cloud events for a certain language, you need to double check what protocol combinations are supported in that SDK and decide accordingly, because not all the combinations are supported in all languages. And there are 3 upcoming specs in cloud events: Discovery API, Subscription API, and Schema Registry. So far, CloudEvents has been mostly about events and how do you describe them and how do you read them. But it's evolving beyond that, and it's becoming more like the event lifecycle as well. So how do you discover these events? How do you subscribe to them? And of course, how do you communicate their schemas as well? So CloudEvents will provide these APIs soon, and then we'll see how it will evolve. This is interesting because the async API that I'm going to talk next, it also tries to do something similar to this. Like it also gives you a way to describe schemas and all that. So it's interesting to see how they will evolve together, and maybe they will merge at some point. I don't know. We'll see. All right, so as I mentioned, in event-driven architectures, you need to decide on the envelope. And I think CloudEvent does a pretty good job of that. And it's open source, and there's good SDK support. There's good vendor support as well. On Google Cloud, we have a product called EventArc that uses CloudEvents. I know Adobe I/O that uses CloudEvents. Azure has EventGrid that uses CloudEvents. So it feels like there's a good momentum around it. So my suggestion is take a look. Don't try to reinvent your eventing format. If you can use CloudEvents, it's a good idea to try it out at least. Now, of course, we still need to figure out which service publishes and subscribes to what events and communicate that. And for that, we have AsyncAPI. So let's look at that next. Before I continue, is there any questions on CloudEvents before I go? Yes, no? OK. Well, let's continue, and then maybe later. So what is AsyncAPI? AsyncAPI, it's another open source specification to define asynchronous APIs. So if you are used to OpenAPI, which is for REST-based APIs, it's similar to that, but instead of REST-based APIs, it's for asynchronous message-driven APIs. And it's not only specification, but it's also tools to visualize and validate async API definitions, and even generators to generate code from your definitions. And I'll show you some examples of this. So again, it's just like CloudEvents, it started as a spec, but now there's an ecosystem around it with tools and generators. There are some main concepts in async API that you need to be aware of. So at the top level, you define an application. That's your async API-driven application. Then you need to define how you talk to this application. So the server is the base level protocol that you need to define. Then under the server, you probably have one or more channels. So these are different topics, basically, that you can use to talk to your server. So once you have all the basics in place, like the server, channel, and protocol, then you will have producers and consumers, or publishers and subscribers, to send and receive messages. And you also need to define your messages, so your message schema. And finally, there's this notion of bindings in async API. Bindings allow vendors to extend async API for their own use cases. For example, Google Cloud has Google Cloud PubSub bindings. That way, you can define Google Cloud topics using async API. And I'm going to show you an example of this later. But these are the main concepts in async API. And one question I always receive is, how does async API work with OpenAPI? How is it similar? How is it different? There's actually a really good website that shows this. So let me show you that. So when you look at OpenAPI, well, first, both in OpenAPI and async API, you have your application info, you have your servers and security, so those are the same. But OpenAPI is path-driven, right? So you define paths that people get to. And then under the paths, you have operations. And these are HTTP operations like get, put, post, so on and so forth. Now, once you have these operations, you also define the requests and responses. And then these requests and responses, they're typically defined under components, right? So that's, you define the shape of your responses and the shape of your requests. So that's what OpenAPI does. Now, in async API, you don't have paths anymore. You have what's called channels. So that's how you talk to asynchronous APIs. So you have a channel, and the channel has operations, but it only has two operations, publish or subscribe, because it's message-driven. So you can only send a message or receive a message. So that's the operation that you have here. And what you're sending is it's a message. It's not really request and response. It's more, the concept is a message with a header and a payload. And just like OpenAPI, you define your message schema down here in component section. So as you see, they are kind of similar in that sense that you're doing similar things. except instead of being path-driven and driven by HTTP, you are message-driven, and you have subscribe and publish operations on your channel, okay? Now, what does an async API definition look like? So this is the simplest definition that you can have. You define your application. You typically give it a revision. Then you need to define at least one channel. So in this case, we are defining a channel called hello. And then you need to define the operation on the channel, in this case, publish. And then you need to define the message that you can publish to that channel. In this case, the message has a payload type string. So it's just a string message. So this is the simplest one you can have. Let's actually take a look at another one that's slightly more complicated. So here, we are defining an async API. You need to define a server. So in this case, we are using AMQP server. So you define your server, whether it's a production server or a test server or a staging server. Once you have the server, you need to define your channels. So in this case, the first channel we define is a hello channel. And the operation on that is publish. So you can publish messages to that channel. And that message has to be of this type, hello message, okay? And we'll define that later. The other channel is a goodbye channel. And you can publish a goodbye message. And then these messages are defined here. So hello message has a payload or object. So it's an object with type, with a name type. Sorry, one of them is called name, and the type is string, and the other one is sent at, that's defined later. The goodbye message is also similar, but it only has sent at field, and that's it. And then when we look at the sent at, it's a string that's format date time. So you see the level of detail you get here, right? You define where's your server, you define where's your channel, what operations you can do on that channel, and what kind of messages you can send. So that's the level of detail you can do with async API. And there are tools around it. So once you have the specification, you can use Async Studio to visualize these async API files. You can use async API CLI to validate these definitions. And then you can use generators to actually generate code from these specifications. And actually, let me show you the studio quickly. So if you look at Async API Studio, and here I pasted, so it's a browser-based kind of tool. You can run it locally as well if you like. But I pasted the same definition here, and then on the other side, you get a visualization that tells you your server. Then you see your channel, so my hello channel, and the operation on the channel is subscribe. Then you can see the message that you can send to that channel and its format, which is nice. You can even get some examples, like, so this is the type of message you should send, name and send at, right? And then similarly, you see the information about goodbye. So this is very useful to kind of visualize and communicate with other people that this is my API, and this is how you can talk to it. And these are some examples. And the other thing I want to point out is the generators. So if you go to this site, there are a lot of generators for different languages. So for example, there's generators for Node.js, generator for Java, Java Spring, generators for .NET, C# client. So they're good generators to get started, basically. So if you have a spec, you can try to use them. And it will give you the basic code that you need to either send a message or receive a message on a certain language. Having said that, I think they're also very limited because they only support very limited use cases. For example, when you look at .NET, it's a .NET C# client using NATS. The Node.js one, it only works with a limited subset of async API. So it's not going to work for any kind of definition, but it will work for a small subset, and maybe that will help you to kind of get started with async API. All right. And now I want to talk about the publish and subscribe semantics in async API. So as I mentioned, in a channel, you can define publish and subscribe operations, right? These operations can be confusing when you're trying to implement because it really depends on whose perspective you are looking at, okay? So for example, when we think about publish publishing on a channel, from user's perspective, it means you can publish a message to that channel. But from the server perspective, it means the server receives the message, right? So that can be confusing because depending on from which perspective you're looking at, it can get confusing because in async services, like whose server, whose client is kind of different depending on, because services, they can receive messages and they can send messages, so sometimes they are servers, sometimes they are client, right? But you should always think about from the user perspective. To talk to the server, do I send a message or do I receive a message? If you send a message, it's publish. If you receive a message, then it's subscribe. And if you're coming from WebSocket term, WebSocket publish is like send and subscribe is receive. So that's what I'm saying, like think of it from the user's perspective. And I actually have an example, so maybe we can go through that quickly just to see how this works. So let's imagine, for example, we are building this very simple architecture, right? We have an account service that publishes a message, user signed up, and then we have an email service that receives a message, this user signed up message from the message broker. So let's say we have this, and we want to define account service in AsyncAPI, right? So we want to define account service, and we want to define a channel on that account service. How do we say, so on the channel, what operation do we need? Do we need publish or do we need subscribe? Who says publish? Okay, a few people says publish. Who says it's subscribe? No, okay. Well, let's take a look actually. Let's think about it. So to talk to account service, do I need to publish a message or do I need to subscribe? Publish? Well, the thing is, account service, what does it do? It publishes a message, but as a user, do you publish to it or do you subscribe to it? You subscribe to it, right? Yeah, let's see if it's correct, because I also get confused about this. So if you look at account service, we define our application and our server, and then the channel is subscribe, because as a user, you subscribe to receive messages from this service, right? And then the rest is basically I define the actual message and what it looks like, so the usual stuff. So this is subscribe. Now for email service, the operation is what? Is it publish or subscribe? Who says publish? Okay, and who says subscribe? Okay, well, maybe it's too late and you don't care. But when you look at it, email service as a user, again, like we should again think of it from the user's perspective. As a user, to interact with email service, what do I need to do? I need to publish a message to it. So I think the operation should be publish, right? So let's take a look. Yeah, so we define a channel, and yeah, the operation is publish. So that's what I mean by the perspective. You need to think of it from the user's perspective to get these operations right. But once you do that, then the rest is pretty much the same. I'm defining my messages, and I'm defining my schema of the messages the same way. And by the way, you can also do something cool in AsyncAPI. Of course, here I'm defining this email service and account service into separate files. And they share a lot of common things, right? The messages are, for example, the components of the messages. The server, it's common. So what you can do is you can create a common.yaml file where you define your common things like server, messages, schemas, things like that. And then you can go to your account service and just refer to them like this. So you can refer, for server, you refer to this common file, and for message, you can also refer to it. And similarly, if you look at the email service common, you can refer to it. So that way, you don't need to duplicate things in multiple places, but you also don't need to put everything together either. So that's one thing that you can do. All right, so let's go back to, let me see my README. Okay, it's here. So once we have this definition of account service and email service, what we can do is we can use the AsyncAPI CLI that I mentioned to validate our definitions. So let's actually do that here. So if I do AsyncAPI validate, then I can see if my definition is valid. So here I think I'll get some warnings, but I know that there's no errors. So that's useful. And then from this spec, you can actually generate code as well. So to generate code, I would just use the CLI and say AsyncAPI generate. And then I need to point to a template. So in this case, I'm pointing to a Node.js template. And I'm pointing to my email service YAML as well. So let's just copy this. And let me just make this 2. So now this is reading the definition, and from there using the Node.js template to kind of give you a simple service that you can publish messages to, right? So the code is generated. I have to admit the code doesn't look that great to me. Like, if you look at the API, the index and things, like there's a lot of stuff here that I don't even know what they are, but it gives you the basic scaffolding so that you can actually run this. So if I go to email service, then let me see, we do npm start. So this will start to generate the code. So now it's running MQTT. And then to interact with it, I can just send a message. So I will send this user signed up message to it. So in a separate terminal, I send that. And then, yeah, I can still receive the message. So if you are playing with AsyncAPI and you want to just get up to speed, I think this might help because from the spec, you can get some basic code and just interact with it. But it doesn't work for all use cases, as I mentioned. For example, I tried to generate Java code from this same definition, and I think it works. It does generate. So let me, first of all, I think I need to get rid of this email service too. And then now if I generate it, it will give me some code. But when I tried to run it, it didn't work for whatever reason, because the template or the Java code, or maybe my setup is not there. So you need to pay attention to these templates. They don't always work, but they're there, and you can add more templates if you want, because they're all open source. All right, so I think I'm almost out of time, but now we have a way to describe which services publishes or subscribe to what events with AsyncAPI. And in the final part of the talk, I want to talk about CloudEvents and AsyncAPI together, because I talk about CloudEvents and I talk about AsyncAPI. So one question I had was, can I use CloudEvents and AsyncAPI together? So can I, for example, describe a service that's publishing CloudEvents in binary mode or structured mode, or receiving messages in those formats, and use AsyncAPI to describe that? And the answer is yes. AsyncAPI is flexible enough to allow that. And let me show you the example quickly. So remember, in structured mode, you are sending your Cloud event in the body. Everything is in the body, right? So how do you document that in AsyncAPI? So if you look at the definition of this, so here I'm defining my channel and I'm defining my message. So I want my message to be a Cloud event. So what I do here is that the key part is here. So here I'm saying that the content type has to be Cloud events plus JSON. And then when we look at the schema, I'm referring to Cloud Events spec. So Cloud Events published a spec on what it expects in a message, and I'm simply referring that from my AsyncAPI. And by doing that, I'm basically defining my Cloud Events in AsyncAPI, and this actually works. And if actually, let me copy this quickly and put it in Studio. And then here, you can see that I get the payload, and I see, the Cloud Event stuff here. I see the data here, which is pretty cool, right? Like, I get that for free, and now I can communicate with people what's needed. Now, the other part to this is, let's go back. This is cool for the structured mode, but in binary mode, we have these headers, instead of the body. So how do I define that in AsyncAPI? Again, AsyncAPI has this notion of message traits. Message trait is a way where you say, in all my messages, I need to have these headers. So what I do here is I define these message headers myself. So I'm defining my Cloud event ones, required ones, and optional ones, and I give them descriptions. And then once I have this message traits file, then I can go to my binary definition. And then here, This time, instead of defining it in the body, here there's a traits section, and I point to my traits. And by doing that, I'm basically telling AsyncAPI that all the requests should have these headers that I define, which are CloudEvents headers. So that works pretty well as well. All right. And then lastly, I said, OK, this is all cool, but can I use Google Cloud PubSub and AsyncAPI together? And the answer is yes as well. And this is possible because of bindings. And just to show you the example, just to show you the example quickly, so here's a PubSub example. And you will see that under channel, for example, there's a binding for Google Cloud PubSub. So these are Google Cloud PubSub specific settings that you can set. And these bindings were created by the Google Cloud PubSub team. So if you're using Kafka or if you're using some other protocol, you will basically use these bindings to kind of bind to that protocol. So by specifying these bindings, I was able to document my Google Cloud topology as well using AsyncAPI. So I'm pretty happy with it, that it's open source, it's out there, and it seems to be flexible enough that allows me to use it in different settings. So that's all I wanted to say. I don't want to keep you here longer than you need to, because I know there's beer waiting. But if you want the slides, this is the speaker deck. If you want many more examples than I showed today, these are my two of my repos. And as I mentioned at the beginning of the presentation, if you want to join the Google Cloud Innovators Program, that's the link as well. Thanks very much for listening. Thank you. Any questions before we go? Yes? No? Maybe? Yeah. Yeah, let me repeat the question. So if I have a synchronous API, do any of these tools help me? And the answer is no, because I mean the whole point of AsyncAPI is that it's asynchronous. So it's like publish, subscribe, asynchronous. That's the point. So I don't think it would help for that case. One more question, yes.
Thanks for the presentation. Can you tell where event-driven architecture is better for what kind of products, if you can share this?
OK, so where is event-driven architecture better? I would say it's better in a few cases. One is if you feel like your architecture will change, so you will add more services or you will remove more services, then event-driven helps to make that easier, I think. So that's number one. The second thing is when you don't need synchronous calls. I mean, for example, let's say service A calls service B, and then service B calls service C. If everything is synchronous, then if something goes wrong, then the whole chain is broken, right? Do they need to be synchronous? If the answer is no, then if you make them event-driven, then service A can send a message to a queue, and if service B is down, service A will still continue working, right? It won't be blocked. But service B will wake up, and then it will find its messages, and it will continue working on those messages. So it allows you to have architectures where part of your system still works without blocking the rest of the architecture. So if you need that, then event-driven becomes a good choice as well. Yep. Any other questions before we go? No? OK, well, thanks very much.